All right, hello everyone and welcome to the Warning Decision Training Division's new webinar series, R2O, O2R, Tails or Roots. This was formerly known as Tails from the Testbed. I am Jessica Blair of OU Cero. I'm here along with Kevin Field of Cero and SPC and Lexi Elizalde, also of Cero and WDTD. Today we'll be going back to our roots with the Tails from a Testbed style webinar, broadcasting live from our WDTD conference room. We have several visiting forecasters here who will discuss their impressions of the new satellite products as part of this year's Satellite Convective Applications Experiment. Our distinguished guests this week are Miles Bliss from National Weather Service Medford, Jason Dunn from National Weather Service Dallas-Fort Worth, Pamela Petrika from National Weather Service Anchorage, and Ty Vaughn from the National Weather Service in Peachtree City, Georgia. I'm now going to turn things over to Kevin Field. He is the lead investigator for this experiment to introduce the EWP and the experiment, and then we'll hear from our visiting forecasters.
Thank you, Jessica. Part of the Satellite Convective Applications Experiment is within the Experimental Warning Program. And so the mission of this program is to help improve hazardous weather prediction and services provided by the Weather Service for then the end user there. And we're going to be using these new and developing technologies, platforms, and techniques, everything from training to even visualization to help provide that for those then end users. We're able to take the knowledge that we have here in the Norman community and our expertise here in the hazardous weather testbed, and being able to then also pull in additional resources as well from several partners and also developers, and bring in their talents and their knowledge along with these the forecasters that we're also bringing in to then test out these applications in these simulated and real-time environments there for not just warnings but also for information decision support services as well. So we're able to complete the the research to operations and the operations to research loop and provide this whole continuous cycle all within these weeks in which we have these forecasters and these very valuable times we have. So as I mentioned, we use live weather in our experiment, and so we go where the weather goes. So this week, across 4 days of experiments, we targeted 8 weather forecast offices and simulated operations within those offices, having our 4 forecasters break into 2 groups of 2. And they were able to then provide their warning services along with distance support services in this simulated operational environment throughout these convective days. So within the experiment, these forecasters looked at 5 experimental and new products that were being assessed here, and they all had various applications and different research to operations questions that they were looking to answer throughout this week. So I'm going to give a rundown of these products, and then I'll hand it over to the forecasters to then provide their input and their feedback from what they experienced this week. So the first product here, a new one to the experiment, was the GLM Background and Data Quality product. This product takes the information from the GLM background image. You maybe have seen the GLM flashes themselves, but the actual background image that's used as a reference to those flashes was made available to the forecaster this week. Using that background image and additional information, on the right there you can see a data quality product that provided the flash detection efficiency there in the green and blue colors. You can see in the yellows and whites there even things like near saturated or pixels that were at saturation for that imager. So getting a sense of the data quality when using the GLM product and those gridded imagery themselves that are currently operational. Next we have Gremlin. Gremlin is a machine learning product that provides synthetic composite reflectivity fields that is derived from 4 bands of satellite imagery in the near IR and then shortwave and longwave IR fields, and then is trained against the MRMS composite reflectivity field. In that regard, so you can provide that more spatially uniform reflectivity estimations there across these areas, especially in areas with little to no radar coverage. Next we have Octane. Octane provides high-resolution cloud-top wind retrievals that are derived from visible and IR retrievals from satellite using these high-speed are available from the mesoscale scenes. So we're using very high temporal and spatial resolution from these data to provide wind speed, direction, divergence, and cooling available at cloud top. Next we have the PHS model. And so looking at a model in a satellite testbed may not seem like it fits, but the data that goes into this model is from the polar hyperspectral sounders along with the AVI This uses a novel data assimilation technique to assimilate these data into a 4-kilometer wharf model. And so being able to provide this as these data to show potential gains and improvements of using these in models, along with for things like short-term mesoanalysis, was of note for this week. Last, we have crop severe lightning cast. This is another machine learning model in our testbed that also uses satellite imagery, but uses some visible and near IR or short-wave IR, and then also long-wave IR fields to provide lightning probabilities for over the next hour for observing either 1 GLM flash, and then new this year we also tried looking at greater than 10 flashes over the next hour and being able to apply that. We also looked at a lightning time series tool, this meteogram tool that can be applied to individual DSS points upon request, and forecasters were able to view then those time series data throughout the day for those different events. So those are the products, and I'll throw it now over to the forecasters and let them talk about their experiences with them.
Hello everyone, my name is Pamela Petrika. I was fully interested in the Octane products, both the speed, direction, and as well as the divergent and cloud top cooling components as well, especially given being up at Anchorage. Satellite imagery is the king up there for looking at data. So just looking at some of the products Octane offers, on the left is the visible daytime speed sandwich, and on the right is the IR nighttime speed sandwich. And the warmer colors denote faster speeds, cool colors the slower speeds. And one thing that really stuck out the first day or two of the test bed was with these stronger updrafts in both the daytime and nighttime imagery. The cooler colors really get highlighted with color curve, and then the warmer on the upshear side of the updraft, and then the warmer colors downstream, indicating areas of divergent flow. So those stronger updrafts really stick out on these products. So divergent flow near the overshooting updraft highlighted in the circles. The IR image is a little more washed out, doesn't show as much detail, but you can still pick up on those cooler colors on both the products. The direction sandwich was also interesting. It took a little more time to kind of figure out, but once you did, some of these divergent signals also stood out. Warmer colors, the pinks through yellow, generally range from 90 degrees to 270, and then the cooler colors, greens to purple, range from 270 back around to 90 degrees. So once you get a hang of the color curve, you can see in those circles on both images, that divergent signal, again, really stood out on those stronger updrafts. Some takeaways on the speed product. It did show a lot of promise in highlighting those speed decreases on the upshear side of those stronger updrafts. There were a couple other things we noticed, but just focusing on the stronger convection for the hazardous test bed, those areas really stood out. Especially you have those strong gradients, divergent flow near those overshooting tops. And then if you paired this imagery with the cloud top cooling products and the divergent products, Octane products as well, it really gave you a lot of information on whether that the storm was initiating, more mature, if that updraft was maintaining itself, or kind of going on a downward trend. It was a little distracting if winds were very light on the backside of the storm with those cooler colors. If they got too light, it looked like they kind of dropped out, but that's more of AWIPS masking those cooler colors. The masking color was in black, so it was a little distracting, but we were able to create another layer to show the visible satellite imagery, to have that come through so it wasn't as distracting with those light and variable winds. And then some takeaways for direction and nighttime products. The direction product did a great job of showing that divergent flow at the cloud top layer. It also, besides showing some of those mesoscale features, it also showed some interesting synoptic features as well. So it'll be fun to dive into that a little bit more. Nighttime products, one thing the IR imagery did was kind of wash out those finer details. So we were able to create a color map layer to kind of overlay on that IR satellite imagery that really brought out those details and made it a much more useful product for seeing those details.
Good morning, everyone. I'm Jason Dunn from Fort Worth, and I had the opportunity to assess the PHS model data during some of our convective events. And in this particular case, we were looking at Columbia, South Carolina, where we had some afternoon convection that we were going to be monitoring. And as Kevin had mentioned, the full analysis took a little while to get used to since we were just jumped right into weather, but it did have some utility. Here you're looking at the 18Z PHS 4 kilometer WRF compared to the HER composite reflectivity output here across South Carolina, and you can see that there is quite a bit of similarity in the composite reflectivity output. Both of these models did underestimate just a little bit how much activity there would be across our area, but you can see that the PHS model with the added sounding data did perform comparably well in this particular area. When we look at some of the thermodynamic parameters here, what you notice is in the PHS model there to the left, the CAPE values really kind of stand out there, and we got to talk to the developers a little bit about why there's notable differences between that and the HER, as you see up to the right there. But the overall pattern of the thermodynamic fields was very well represented. As we got closer to the coast, there was quite a bit more instability, and the convection that we did have did intensify in those areas. We had some storms off to the north, which kind of just self-maintained for a while as they had a little bit less instability to work with there. This is one of those products that I think we're going to have to assess in more detail, particularly in an operational setting where like the thermodynamic fields were considerably higher in the PHS data compared to the HER and NAM-NEST. I think initially that might be a little bit of a deterrent for it to be used operationally, just as you see the vast differences there, but it did generally do well with the placement of mesoscale features, and that's what I'd like to look at a little bit more when I can have some time to focus on it. So,
hi everyone, Miles here. I got to take a look at the GLM background imagery, and in the bottom center picture there, that's what we started off with, 4-panel, where the upper left is the saturation and the upper right is a recreation of the visible satellite channel that's also in the bottom right of that picture. And so in this case, you see a streak in the upper left with some yellow pixels in there, and so that's an indication where you could have some bad GLM data, which is really crucial for understanding how much trust you want to put into that product. And one of the things that we played around with was how to take these 4 panels and make them into one, partially so that it takes away a little bit less screen space, but also so that you can gather the information more quickly and decide whether or not to take action on it. And so on the right-hand side, those 3 images are 3 different attempts at visualizing that same data on a single panel. One of the great things about this product is that as an operational forecaster, I am asked to provide confidence to my partners, and here what I'm getting is confidence information from the developers of these products. And so not only will that improve my decision making, it'll improve how my partners downstream can act on that information and also make decisions. So the next thing I get to share with you all is the lightning cast. This is something Tyvon and I worked on. We're bringing you into a DSS event, so we're supporting a partner out in the field. They have people outdoors with lightning storms all around. And one of the things that we set up in the lightning cast tool is one of these meteograms, and that's what you see pictured there on the right. The yellow and red lines indicate confidence that lightning is going to occur over a certain amount of time, and in this case you can see it's 100%. With the blue dots underneath is the GLM plotted, so you can see that there was lightning activity in the area. And this was a great simple way for us to sit down with our partners and discuss with them how lightning is going to impact this event and see how their actions were going to change as the probability ramped up. Some of the other stuff we did, though, was internal to operations, just taking a general look at things. So in the animation on the bottom left, there's a little home area where we had our Quartet Festival, this decision support event. And normally, lightning cast is displayed as contours, but in an operational setting, that can get a little jumbled. So we were able to play around with mapping this as an image overlaid with the GLM data there. And it made a much smoother, easier on the eyes appearance that we think will have more forecasters excited to use this product. Now the other thing we wanted to play around with is on the right-hand side, which is taking the previous color scheme, which had three contours. It was like a green, a blue, and I think a red contour, and bring that in line with the risk matrix mindset or the color-coded mindset that the National Weather Service is moving towards, such that we have a standardized product across the entire Weather Service. And that's what you see adjusted here with the addition of a couple extra lines to give us a little more confidence at a further time scale. And so this tool is already being used in some places around operations as it's available online and the AWIPs. And we thought not only the added features provided to us here in the form of the dashboard, but the increased flexibility within AWIPs is going to make this a much more appealing product to be used around the Weather Service.
All right, this is Jason. I had the opportunity to work a little bit with the Gremlin product, which is the satellite-derived radar reflectivity product. And when we first started here, we had a couple of cases. The one on the left was the Columbia, South Carolina case, and you can see it was a little coarser resolution. We got to work with the developers to understand that that product is actually a little higher resolution, which is what you see off to the right there. And we had a couple of cases where we got to use this with some of the octane data and determine its usability in operation. For this particular case, we were looking in San Angelo. We didn't have a lot of weather in our area at this time, but we did have three distinct little cells off to the north. And I will say in this particular case, we were not allowed any radar data or MRMS data to look at. So kind of simulating a case where you may have poor radar coverage or no data at all. And so we only had the Gremlin product along with some of the satellite products that we were. And when you use Gremlin in conjunction with, say, the octane products, you can really increase your confidence in what you're seeing and your messaging. So in this particular case, we were looking at the octane speed and direction sandwiches, which are the top images in the floor panel on the right. And you can see that the speed, in the speed imagery, it's fairly uniform across those storms, no notable direction changes. In the divergence and cooling products on the bottom, there was some storm top divergence, which you can kind of see the taller echo and Gremlin there, but it really didn't maintain itself. A mesoscale analysis suggested that as those storms move off to the north, that they were going to become in a less favorable environment, which was about 20, 30 minutes later. And you can see again, using Gremlin with the octane products, again, that uniformity in the speed and direction, there was a decrease in the storm top divergence, and those cells weakened as they moved off to the north. So being that we had absolutely no radar data, no MRMS, our confidence in being able to effectively message was still pretty high with these products. As I mentioned before, I was initially skeptical how useful this product would be, but when you have no radar data and that's all you have, and you have some of the Octane products that you can use in conjunction with it, it really was a useful product in the absence of other data sets to look at. There were some latency issues which we talked to the developers about, and those appear to be able to be overcome, where we can get that product in on a mesoscale domain time sector, which would be super beneficial. And again, using that with the Octane products, I thought resulted in a really, really useful product.
All right, if anyone's looking for more information, please look at the links here on our slide. If you are looking for any previous routes or tales from the Testbed webinars, that link is listed here as well. And with that, we'll begin our Q&A session. If you have any questions.
We do. Our first question is, were you guys calling mesos so that Octane could be used over a certain area, or just using the NWS called mesos wherever they happen to be?
That's a good question. So there was one case this week where we did have to request a meso, and then they ended up we were able to have one moved in that area. But most days we end up being pretty fortunate that when you have anything with a slight risk or above, that usually SPC puts in a request for a meso, and they can get that there pretty readily. And so most days things line up pretty well, but on those rare cases we can submit a request for a mesoscale scene and get that data for the forecasters wherever we'd like to operate on that day.
We have another question. Does Gremlin use GLM as one of the inputs in addition to the 4 ABI channels?
Yes, it absolutely does. The lightning is actually pretty important to identifying those strong convective cores.
I have a question for you guys, if you'd like. So what did you learn this week that you will be taking back to your home offices?
I learned that there's a lot of research going on that doesn't necessarily reach operations unless you come to these hazardous weather test beds. So not only on myself is it important to discuss the things I learned here back at my office, but also as a National Weather Service and larger NOAA organization to better communicate the developments in the research community so that we can start trying these things out in operational settings, really expand the reach of all these products and find new uses.
Yeah, I would agree with that totally. A lot of times from the day-to-day, we are not aware fully of what all is available out there, what people are working on. And I think, I don't know, I think being able to dabble with some of these products even before a test bed, you know, or at least see what's going on out there can give you a heads up for, you know, some of the things that we ran into, you know, like imaging and things like that, how we use things operationally.
Yeah, and I agree with both of them. This is my first test bed, and I found it extremely useful to have the developers here and talk to them, because they're looking at all these products from a developer standpoint, whereas we're out in the field, so it's a good collaboration. They think we might want or need something, but we can fill them in on, well, this would really be useful, and they can make changes pretty much on the fly, as we've seen this past week. So I think it's a great way to get input from the operational setting into these products. So if you don't think they're useful, this is one way to get your ideas of how it would be useful into that product.
How did the PHS forecasts compare with radiosondes?
I didn't do any one-on-one comparisons with the radiosondes, although we did look at a couple of them, right?
So I took a few looks at the products here, and it's surprising how similar the radiosonde observations and the PHS model overlap. Even the RAP analysis being used as well. It's very, very similar, but you do notice fine, minute changes in the moisture profile especially. And as we saw from Jason's example there in the Cape fields, it has big consequences down the line in the model output for differences in those parameters. So even though they're fairly similar, it makes a big difference.
Yeah, we also noticed that on our case yesterday, we did have a sounding from our area and just comparing it to the PHS sounding, just the CAPE values. The PHS was a little high, so just being able to compare and reevaluate, get a better feel for what the CAPE values actually were.
To any of the product developers who are in the room, are there any changes you now plan to investigate to the product based on the forecaster feedback this week?
Yeah, I can start. This is Kyle Hilburn, the Gremlin developer. So for starters, we actually did make some changes this week to improve the resolution. Seeing it in AWIPS kind of showed it in a new light that we hadn't seen before, so we were able to find that issue. Really, one of the biggest pieces of feedback was the latency. On AWIPS, things come in as tiles, whereas Gremlin waits for the whole full disk before it provides the estimate. And that latency on a full disk cadence starts to become an issue when you're doing warnings. So providing Gremlin on the CONUS sector and the mesosectors is something that would help support the forecaster's decision making.
And from an octane perspective, there's a few things we'll be looking into, especially for the IR and nighttime side products. We want to look into how to bring out more detail that the forecasters are used to looking at. It's really useful to come here and talk to the forecasters and, basically directly ask them, what do you look at in some of these severe weather scenarios? And would these products be useful? Would these products be used as is and in their current state? And we had a lot of good feedback to say, hey, I need more information on the evolution of the cloud tops, not just the paintball, for example, that was shown earlier on the slides. And so we'll be looking into ways to bring out that texture. We'll also be looking into ways to smooth and bring out more information out of the cloud top divergence product downstream. And then, of course, eventually looking into better training and highlighting specific things that we think forecasters will be using our products for, or perhaps replacing current standards products in the future. So we got a lot of good suggestions here.
Yeah, from the PHS perspective, as was noted, there are some differences in unstable areas with regards to what the very high resolution water vapor data from the ABI and the polar sounding data. And as pointed out, these differences do make quite a difference in the forecast, especially in small scale storm features, convection, and so on. But as was also pointed out by the forecasters, which is very important, is that the discrepancies might cause the user to be a bit suspicious of whether these are improvements or not. So it's very important that we validate these differences as being real. And we can do that, of course, with conventional radio sound data and so on. And that's one thing we'll do for next week, is have that validation online so that give the forecasters more confidence that differences they see are real and not just due to error. Not that the product is perfect. Any product is perfect, but the case shown here was a very good case to at least make us be able to defend the integrity of the very high resolution water vapor product.
All right, it looks like that is the end of our questions for today. So I would like to thank Kevin, Lexi, our listening forecasters, our developers, and thank you all who attended today virtually for joining us. We hope you would join us for another Roots webinar. We hope that you guys have a great afternoon.